Hello everyone, this video is for reviewing KSAT math problem. KSAT stands for Korea Scholastic Aptitude Test. Um, this is a test for students who want to admit university in Korea. Okay, on this problem, I want to deal with the math problem, optional probability problem. Admission year is 2024. This is an odd type. Problem number is 28. This problem is about conditional probability. This is only has one point, that is conditional probability. Okay. When we try to figure out probability and when we know some information such that event, for instance, a certain event happened, let's say Q has happened. I know this one. On this state, the probability value that I want to figure out, the probability of event R, say, could be different when the probability of R given Q could be different. In general, they are different. Okay. The right hand side one is called in this case, we repeat trial 4 times. This is the trial here. Each trial, this trial has probability 1/4. This probability has, this trial has probability of 2/4. This trial has probability of 1/4 respectively. And what you get is we have only one whiteboard. On the second trial, we have one whiteboard and one blackboard. We have two boards. For the third trial, we have two whiteboards and one blackboard here. Okay. And then after a fourth trial of this one, okay, let's say we have 4 trial, 1, 2, 3, and 4. What's the case that we have 8 balls in the box B here? The easiest one is the number of balls in box B is 2, 2, 2, 2 for all the trials here. We have 8 balls. Other case, maybe we have, instead of this 2, 2, we have 1 and 3 here. 1 white ball and 3 ball, which consists of 2 white ball and 1 black ball, and 2, 2. Or maybe we have just 1 3 1 3, and this type of trial result here, uh, they all satisfy that the box B should have 8 balls. But the trial has a sequence here: first trial, second trial, third trial, and fourth trial. So this is a permutation, order matters, permutation. In case of permutation, we only have one case. Okay. In case of on the perspective of permutation, we have 4 factorial over 2 factorial, because those two can switch their position, but it does not change. It does not change the result, so we divide it by 2 factorial. On the third case, 1 3 1 3 type, this should be 4 factorial over 2 factorial divided by 2 factorial times 2 factorial, because those 2 3 and those 2 1 can change their positions independently. And then probability that this type of event happens is that only 2 2 2 2 full time. That means the second trial, it happens 4 times here. In this case, 1 3 2 2 type, the first trial 1 time, and the third trial 1 time, and the second trial 2 times here. And this type of event has 2 times of trial 1 and 2 types of trial 3, like this. Okay, and then what's the case of event R here that we are looking for here? To only have 2 black balls in the box B, 2 black balls. Black balls comes from either the second trial or the third trial, so we should have only 2 third trial or 1 third trial or 1 second trial. In this case, we have 3 black balls. This case is 3 black balls. This case, we have 4 black balls. This case is 2 black balls. This is what we want. So this is the event R. Let's say this is the event R. Okay, so if you compute these whole things, it's a 1/16. And this is 4 factorial over 2 factorial is 4 3 2 1 over 2 times 1. So they are cancelled out. 4 times 3 is 12. This is 12 times 4 to the 4th power 256, I believe, times 4. And this case is another 1/2, so 6 times 1 over 206. The probability of event Q is the value of sum of all these probability here, and this is actually Q&R event here. Let me be more precise. This is precise, and then the probability of event R and Q or Q&R, it does not matter, is 6 over 256. Okay, let's wrap up this problem. This is rather straightforward, because this is kind of stereotype of conditional probability problem, and then the main point is that you have to divide two events. One is a prior one, and then the second event R, this is a posterior one, and then you use combinatories very carefully, and you can compute the probability of each event, and then you just put the values on here. Okay, that's it.